Hello, welcome to this video. So this video will be about a conventional question in paper 1 of DSE about equation of circle. Well, I'm afraid this problem is quite integrated. As you can see, this is the last problem of this paper. Anyway, so we need to rely on the figure. So we need to sketch, well, not just a figure, I'm afraid, a couple of even a number of figures, in this question. So we have the center of circle C. So first of all, we have a circle. Okay, so this is circle C. And then the center is G. The point A, with the coordinates lies outside C. Okay, so using so you can see the x coordinate is the x coordinate of A is 158, while the x coordinate of G is 83. So you can see A, so should be on the right hand bottom corner of point G. So A would be the right hand bottom corner of G and lying outside C. So that's why A somewhere here. So find the equation of the straight line passing through A and G. So now we have we got the point A, we got the point G. So easy. So part A. So maybe y minus 12 over x minus 158. Right. Okay. Negative 4 over 3. So if we try to do a cross multiplication, negative 4 over 3, so 3y minus 36, negative 4x plus 632. So in general form, 4x plus 3y minus 668 equals to 0. Right, so that's part A. Right, part B. Find the coordinates of the point of intersection of AG and PQ. So where's PQ? AP and AQ, are the tangents of to C at the points P and Q. Okay. And then we have C also passes through another point. So 23. Okay. Like this. And then now it doesn't really matter about the naming. So the tangents. So PQ somewhere here. PQ. So PQ and AG. So I'm afraid for B, we find this point. And then maybe we try to denote this point as H then. So B, we try to denote the point of intersection of AG and PQ by H. Alright, so well, is we are given some hints lists, okay, because okay in part A we have the equation of AG, so that means okay we need to find the equation of PQ. We need to find the equation of PQ, and then here you can it's quite clear that APQ okay would be an isosceles triangle. Now I'm afraid okay so PQ is a chord. So and then a line from center to the midpoint of chord. Okay, so I'm afraid some circle geometry. So you can see PQ okay will be perpendicular to PQ okay is perpendicular to line segment AG. But PQ okay we do not know anything. Okay, so that's why here okay we can try to have some calculation because a G has been given. So G is 83,112. So we can find out the radius. So 60 squared plus the square root 75. So this is 75. And at the same time, so you can see A, okay, so would be, this is given to be 158. And then this is 158, right? And 12. Okay, good. And then surprisingly, so you can see that okay, so you can see that this one. Alright, so you can see that if this is 75, we try to look at this. So you can see that, note that 83 plus 75 is coincidentally equals to 158. Alright, if you just try to consider the x coordinate of point G as well as the coordinate x coordinate of point A with the radius. So what does that mean? That means in this case GP is horizontal, or maybe GP okay in this case is horizontal, but P can be Q depending on the naming, right? So that's why here we can say that P will equals to 158, 112, or Q equals to 158, 112. Okay, so let's say P. Okay, my figure is using P to be simple. That means very important. Okay, so you can see that AP is vertical and GP is horizontal because of tangent perpendicular to radius. Things like that. Okay, so that's why okay we have P now. Okay, so P will be 158, 112. So that means okay we have 1 point. Okay, in the line segment PQ, and then we have the slope as well because okay from the above the slope here okay so the slope of AG is -4/3. That's why the equation of PQ, so that would be y minus 82. I mean 112. Poor handwriting. So from this, so we can find out this is 3/4. And then by cross multiplication, that will be 3x minus 4y. Okay, minus 26 equals 0. And then, okay, if this is equation 1, this is equation 2. To solve these two equations, so solving 1 and 2. Here, okay, I'm afraid we can make use of the program to help us. So solving 1 and 2. Okay, in that case, h will be 110, 76. And that will be just part A and part B. Okay, so let's go to part C. So find the equation of the circle of triangle APQ, not the inscribed circle of triangle APQ. So let's recall, first of all, okay, so we have the point A outside the circle, and then supposingly we have a P, which is vertically above A. So and then the coordinates of A that will be given from the question. And then for P, okay, in part B, okay, so this is 118, I mean 158, or 112. They are vertically above. So you can see that AP is, based on this, AP okay, is 100. Good. Alright, so and then we don't know the coordinates of point Q. We do not need to make use of that. But don't forget, AQ, okay, will also be 100 as well, because of the tangent properties. Because AP and AQ, they are both tangents to the circle C. Okay, so and then that's why that makes APQ, okay, this triangle, okay, is an isosceles triangle. And then just now H, we have the coordinates here, which is 110, 76. Okay, good. We do not need the answer there. Okay, good. So don't forget, of course, H, okay, will be the midpoints, because AH is perpendicular to PQ. Now, okay, we want to find part C, right? So part C, which is the inscribed circle. Not so bad. The inscribed circle. We want to find this. So of course, for any circle, so we have the center. So we try to denote the center to be K. And then the corresponding radius will be R. So let's try to write. Right, denote the in center and the radius of the inscribed circle of triangle APQ by capital letter K and small letter r respectively. Alright, so we have AP, we have AQ, so let's try to find HP. So HP using the distance formula. So which is 60. So 60. Okay, so here we try to use the usual trick. So if HK is R, the in circle is R, we try to decompose, okay, the blue triangle APQ, okay, into 3 parts. Okay, so with PQ as the base, AQ as the base, and AP as the base, try to decompose that, okay, into 3 triangles. Just like that, follow the yellow line. Alright, so we have, so along the 3 yellow lines, okay, we try to decompose or divide the blue triangle into 3 triangles, okay, with AP, PQ, and AQ as the bases. And the heights, okay, of these 3 triangles are all ALU. Okay, so that's why, well, we need also AH as well, right? So anyway, so because, okay, we want to find the area of the whole triangle, so that's why here is easy. We just try to make use of any AHP then. So AH, I mean 100 squared. So in that case, AH, okay, will be 80. Okay, so that's why here, okay, so right, so here we can use R times 100 divided by 2 plus R times 100 divided by 2, and then plus R times 60 divided by 2, and then 16 times 2 divided by 2. And then, so the sum of the areas of these 3 triangles, okay, will be equals to the area of the blue triangle, which is the triangle APQ. We can take 60, or take 60 times 2 as the base, which is PQ as the base, then AH with the height. That'll be 80. So 100, 160. So okay, in that case, R equals 30. Alright, so we want to find the equation of the circle. So now we have the R. Okay, we need to find K. Okay, so and then for K, we just try to consider like this. So A is 158.12, and then H is 110.76, and then K somewhere here. We need to find K, and then HK is 30. This is 30. And then AH is 80, so that's why AK will be 80 minus 30. So you can see that will be 3 to 5. 3 to 5. Oh, okay, good. So let's write down the ratios then. HK to KA equals to 30 to 80 minus 30, which is 3 to 5. Good. So that's why here we can find the coordinates of K using the section formula. So let's use the calculator. $128. So 52. So now we have the in center. So that's why finally the equation of, or simply the required equation, come on, right? So the required equation, x minus 128 all square plus y minus 52 all square equals to 30 square. And that will be the answer for part C. Okay, so let's look at the last part, part B. So suppose, someone claims that the ratio of the area of the inscribed circle, or the inscribed circle mentioned or found in part C, to the area of the circumcircle of triangle APQ, or APQ again. So that's why, okay, we have APQ triangle is 1 to 4. Anyway, so but first of all, okay, we need to have the circumcircle of APQ. So from the previous parts, okay, so we have point G, so point G is here. So point G is the center of circle C. So and then PQ will also be some points, okay, lying on the circle C. So that's why, okay, if we try to link them up, I'm afraid angle AQG and also angle APG will be 90 degrees. Because of tangent perpendicular to radius. Good. Alright, so that's why we have a pair of opposite angles. So since AQG plus angle APG, so this pair of angles are supplementary. Well, I'm afraid in that case, APGQ is concyclic. So in that case, AG will be a diameter of the circumcircle. Well, that means, okay, the circumcircle, the required circumcircle, not just passing through A, P, and Q, but it also passes point G. So that's, and in this case, AG, okay, is a diameter. And then don't forget A, okay, we have the coordinates. A is 158.12, and then G, okay, is also given 83.112. So that's why AG can be found. And then we can have the radius of the inscribed circle. Right, so that's why here we can find out the radius of circumcircle, or simply the circumradius. So equals to distance formula again. So 125, this is the diameter, okay? This is the length of a diameter. So that's why we need to divide by 2. So as to get 62.5. Okay, good. So this is 62.5, and then from above, so we know that we have 30 here, and then we have 62.5. So that's why the required ratio was close to 1:4, but it's not. Okay, so that's why the required ratio that would be 30 square to 62.5 square. So that will be equals to 144 to 625, but not equals to 1:4. That's why the claim is disagreed. And that's all for this part as well as this video. Thank you for watching.